Hi everyone, I'm Arthur Breitman of Tezos. I'm going to give you, I'm not going to go next to this microphone. I'm going to give you a short talk on governance and in particular how it applies to blockchains in general and to Tezos in particular. So the first thing I want to talk about is conflict. So in general, I like to divide the conflict that people can have into two kinds of conflict. You can have a conflict over a scarce resource or a conflict that's not about a scarce resource. And if a conflict is not about a scarce resource, for example, I have my neighbor and, for some reason, my neighbor likes to shave his head and I don't like that. Or, my neighbor likes to dance a certain way, I don't like that. So that's not a conflict over the scarce resource, that's a conflict over what he's doing. And the way that you resolve this conflict is you say, okay, just ignore what the other person is doing. And as long as you can kind of isolate yourself and say, this is, I'm not going to, this is actually not going to affect me directly if I just ignore it, then that's a very, very good way and peaceful way of resolving conflict. And then you have conflicts which are over a scarce resource. So for example, there's this piece of wood and I want to use it, my neighbor wants to use it. And once you start having a scarce resource, you cannot resolve the conflict by just ignoring the other person, because if I ignore the fact that my neighbor wants to use my piece of wood, then I'm not going to have the piece of wood, and that's a problem. And the way that you solve this second type of conflict is by having property rights. So essentially, you're going to have a way of defining who owns the wood, and if I own the wood, then the way to solve that conflict is I get to decide what I do with this piece of wood. And if you own the piece of wood, you get to decide what you're going to do with the piece of wood. And that's a great way of resolving conflict. So, if there's no scarce resource, just ignore the other person. If there's a scarce resource, have a property right. Now, that works great. And the problem starts when you want to have resources which are shared by many people. Sometimes it can be really hard to give property rights over things. So, you could have something like the atmosphere, which is shared by many people. You could have a thing like a river, or you could have a thing like a blockchain. And I'll get to that. So whenever you have a shared resource, you do have the conflict problem again. You're going to have this shared resource. Many people want to use it a different way. The way that they use it can conflict. And you need to have some sort of procedure for resolving conflict. And that procedure is what I call governance. So if you look at a system like Bitcoin, the first thing you think about is private property. Bitcoin is digital property. I can own my Bitcoin on a blockchain. You can own your Bitcoin on a blockchain. It feels like there shouldn't be any conflict because they are very clearly delineated property rights on that blockchain. Or you could have a multi-signature contract, but in which case there's a very, very clear rules about what can happen. And so when you think of the systems, governance is not really what jumps to mind. It doesn't seem like it needs governance. Now, however, on a system like Bitcoin, the resources are somehow artificially scarce. If you take something like gold, the scarcity of gold is enforced by the rule of physics. But in Bitcoin, the scarcity of Bitcoin is enforced by the rule of consensus. The only way for me to really own my Bitcoin is to make sure that everyone agrees that I'm the one owning this piece of property. And that makes it, and that it turns out creates a big difference. And the big difference is that in order to power this algorithm, the way that blockchain, decentralized blockchains do it, is that they will give pecuniary incentives to miners or validators in order to reach consensus. They will make sure that there's economic incentives for everyone to agree on these transactions. And these agreement procedures, this entire ecosystem of miners or validators or users of a blockchain, they're actually sharing this resource. And the resource in this case is a consensus. And when they share a resource, there can be conflict. And we saw that in Bitcoin, for example, when a conflict arose between miners and users of the network. It's been a couple years now that Bitcoin has been looking for solutions to scale. One interesting solution, which was presented earlier, is a Lightning Network. But the Lightning Network requires the adoption of SegWit. Now, as it turns out, there were some miners on the Bitcoin blockchain who use a special algorithm for mining. And for them, it would be expensive to switch to SegWit because they were using some hidden algorithm in order to improve the efficiency of their mining. So now you have conflicts, because even though the Bitcoins themselves can be private properties, the entire system is shared by these many actors. And as it turned out, in Bitcoin, there was really no rules for resolving this type of disputes. So one way to look at it is to say, well, actually, we have rules, we have hashing power, and if all the miners agree that they want to hash a certain chain, then the total hashing power is going to be what decides governance. But that's not necessarily a very good governance mechanism, because it doesn't exactly achieve what you care about. What it does achieve is it says, well, the people who own ASICs are going to have the last say, and that's not necessarily the same thing as the people who own the tokens. But it actually is even more complex than that. So one example you'll often hear discussed is the idea of a fork, for example. So people will say, well, we'll have a soft fork, and what the miners will do is they will just mine on the chain that they care about. And that way, the majority of mining will go to that chain. Now, if you look at the economic incentives in Bitcoin, your incentive as a miner is to mine the same chain as everyone else. And as a result, you don't necessarily going to want to mine the best chain. You're going to want to mine the chain you expect other people are going to mine. And so this dynamic was described by Keynes as a beauty contest. The idea is that a newspaper runs a beauty contest, and the way it is, and there's a prize, and in order to win the top prize, you need not to pick the most beautiful person on a panel, because that's subjective. You need to pick the person that most people will think is prettiest. And if you look at these games, it ends up not being about what you prefer, but what your expectations of other people's expectations are. And that is what is often called a focal point or a Schelling point, named after Thomas Schelling. So the idea of a Schelling point is we don't have any coordination, but somehow we need to coordinate without communication. The one example I like to give is, let's say that you and I want to meet. We know that we're supposed to meet in Paris, but we don't know where and we don't know when. We know just the day. And the natural thing to do, what most people will do, is you meet each other under the Eiffel Tower at noon, because that's the obvious thing to do, and that everyone will converge on that ID. And right now, most of the blockchain systems, the type of governance that they have is Schelling point-based governance. You'll have people propose hard forks, but what matters in a hard fork isn't so much what you prefer. Because if there's a hard fork of a token into some other, that splits into two currencies, for example, Bitcoin seems like it seems like there might be a hard fork of Bitcoin with a version called Bitcoin Cash. What matters isn't what you think of Bitcoin versus Bitcoin Cash. It's what the market is going to think. It's going to be about legitimacy. It's what people think is a real version, and that is what's going to decide pricing. And it has nothing to do with merit. It has to do with legitimacy, and it has to do with expectations. In general, if you think of the way that people hold power today, when you think of power, you think mostly of physical power. Maybe I have power because I have a gun, or I have a tank. I have, this way of projecting physical power. But look at someone, for example, like Kim Jong-un in North Korea. Now, Kim Jong-un is probably, I'm going to venture a guess, that he's not very good at hand-to-hand combat. So it's not like he's personally powerful. He probably doesn't even carry a weapon on him. However, he has guards. Now, why do the guards obey him? Well, there's loyalty, but there's also the fact that if a guard disobeys, he's going to be killed by the other guards. And why are the other guards going to kill them? Well, if a guard disobeys and another guard fails to kill the one disobeying, then the other guards have to kill the other guard for insubordination. So in the end, you just start by someone who naturally, physically doesn't have much power, but which can hold power over an entire country. And the way this works has nothing, it has nothing to do with his physical strengths. It has to do with the ability to control a game theoretic equilibrium. It's the ability to say, hey, I'm the leader, and everyone recognizes me as a leader, and everyone knows that everyone recognizes me as a leader. Therefore, this is what's gonna go. Now, there's this tendency in this space to think that if you have a hard fork and you let everyone choose what branch they want to use, you'll say like, let the market decide, let people decide. Actually, none of these people are going to decide. What they're going to do is they're going to look for a shelling point. This shelling point might be a core development team. If you have a very, very visible and communicative core development teams, they might just say, well, we'll go with what they say because that's what we expect other people to do. Or that's even that's what we expect other people to think. It might be something like legitimacy. It was extremely strange, but if you followed the block size debates on Bitcoin, you had technical arguments, but you also had a lot of arguments which were people trying to quote Satoshi Nakamoto, the creator of Bitcoin, to each other. They would say, well, Satoshi said that, this is how we need to be on to scale. And other people said, no, look at, this little quote that he made, clearly that indicates support for our position. And you might, so one explanation for that is they say, well, clearly this guy understood the system very well, and he's able to reason about it correctly, and therefore we should go with what he says. But I don't think that's what's happening. What's really happening here is just a play for legitimacy. You want to know that you're the official branch, you're the natural way of going forward, and therefore people should congregate towards your vision of things. So how do we break that? And I think the way that we address this is by having explicit governance, is by saying instead of having everyone try to capture the flag of legitimacy, we have a procedure that's precisely set for deciding how we move forward and how we manage these commons. So the idea of, I've been working for the past 3 years on a blockchain called Tezos, which is supposed to launch in a couple of months. And the idea behind Tezos is to make this governance procedure very explicit. We have blockchains, and blockchains are coordination technology. So let's actually use it for making governance decisions. Voting on a blockchain is something that's relatively easy. Measuring stakes on a blockchain is something that's relatively easy. So the basic idea is you get everyone who owns a token and you decide on a very precise procedures that they're going to have in order to make this decision. That can take a very simple form. It could be a vote. So you can have every stakeholder who owns token say, okay, I own 10 tokens, I have 10 votes. I'm just going to put my votes out there, and then we'll tally them, and then we'll have a decision. And we automatically apply this decision to the ledger. What this does for you is that it recreates a very natural way of moving forward that cannot be captured just by clouds. It's explicit. And I think that's, if you look at something like democracy, one of the main advantages of democracy is not necessarily that it makes good decision, but that it makes stable decision. It's a way of peacefully transmitting power from one group to another. It mostly guards you against really, really bad outcomes. It's not meant, an election is not meant to pick the best person because there's just simply not any information out there. It's meant to say, okay, if someone is really, really bad, at least we can get them out after a few years and replace them with someone. And the way it's enforced is very, it's not like all the voters are going to go out necessarily and remove someone from office and physically put someone from office. It's just that everyone accepts that this is how things work and this is how things are actually going to take place. And so the argument against governance as it is, so there's basically 3 classes of arguments levied against it. One is to say, well, governance is bad. Governance means that people can meddle in things. They can change the way that these algorithms work, and we don't want any change. We want to have fixed rules. We don't want politics. Politics ruins things. And I agree, I hate politics. I don't want politics. The problem is that politics is like the weather. It's going to happen no matter what. And so the argument of saying we don't want governance because that's politics is like saying we don't want an umbrella because rain is bad. You do need a governance procedure to guard yourself against the informal governance that is bound to happen. Now, the other argument is to say, well, we don't want governance because we want a market-based system. We want to have many different competing versions explore different possibilities and let the market decide. But as I've pointed out before, a lot of these networks derive their value from network effect. And so what the market is going to decide is not necessarily which technological solution is best, but which technological solution people are going to congregate towards. Maybe over the very long term, the best solution wins, but that takes a lot of time. Now, the third class of objection you'll get is to say, well, if you have a governance procedure to decide what to do, and some people disagreed, what's to prevent them from going out and doing their own thing, right? So you say you had 60% of people vote for one version, 40% voted for another version, and they just split ways. What do you do then? Well, that, I think, is based on a mistaken assumption. The assumption is that people who want to do things a different way want to part ways. There's an interesting game in game theory called Battle of the Sexes. And in Battle of the Sexes, you have a husband and a wife, and they want to do different activities. I'm going to mix it up a little bit. We'll say that the husband wants to go to the theater, and the wife wants to watch a baseball match, for example. But they both want to do their own activity, but they both would rather do the activity together than do the activity separately. That is, the husband would rather watch baseball with his wife than go to the theater alone, and vice versa. Now, in a game like this, their incentive is actually to lie. They have to convince the other one that, no matter what, I'm going to do my activity. And so, it's take it or leave it. So they're going to be pushing very, very hard, trying to convince how committed they are. But in the end, once the decision is taken, they're actually going to reverse. And I think the same thing happens with blockchains. A lot of people, they claim that they will go their own way, that they have to do it a certain way. But actually, that's just a pre-commitment trick. What they want to do is they want to steer the main blockchain. They want to steer the main economic cluster. If they fail to do that, they will still use the main economic cluster. So the idea of going many, many ways doesn't really square with the idea that these networks have a lot of network effect and that there's a lot of value in keeping them together. So that is basically the mechanism and the underlying idea behind the governance in Tezos. And so we start with voting because that is the simplest thing you can do in terms of governance. We have voting where there's a quorum of 70% and a majority of 70% within that quorum. But over time, this governance model can improve, and I think that's very necessary. Most human institutions today have governance, but that governance is encoded into customs, it's encoded into law, it's encoded into case law and precedents. So it's very, very hard to try to replicate in code something as complex as the governance rules which have evolved for centuries in human institutions. So you start with something small, but then you modify your ledger. You use your governance mechanism to bootstrap better and better governance. So starting with voting, we can introduce checks and balances. We can introduce elected bodies which can actually vet the results of the vote. We can introduce counterpowers. We can even introduce something which I find particularly interesting, something called, I like to call constitutionalism. The idea being that you can pass rules on your ledgers that say, hey, no matter what we vote in the future, we will want what we vote on to have certain properties. So let's say that you want to say we never want to have more than 3% inflation a year. You could pass a rule that says any subsequent rules that wants to increase inflation by more than 3% a year needs to come with a 90% majority instead of 70% majority. So there's a lot of things we can create. What we've built essentially is a seed for governance, and hopefully it grows into a complex and robust governance system that will let people manage the commons that is a blockchain. And thank you. I can take some questions. I don't know how I'm doing on time. So the question is, what stops a bunch of people who have a lot of coins from changing the rules in their favor? That's an interesting question. So in traditional corporate governance, the question is, how do you protect minority shareholders from majority shareholders? And the way you do that typically is through courts, by having minority shareholders take majority shareholders to court and say, hey, that decision you take was not in the interest of all shareholders. So that's really hard to replicate because, like I said, there's hundreds of centuries of precedents in court that let you judge that, and you have humans who can interpret situations. So how do you replicate that in code? Well, fortunately, we have a big advantage here. When you have something like, let's say you have an oil rig company. You have a company that owns a bunch of oil rig, and you happen to be a majority shareholder. You have 51% of that oil rig company. So you own about half an oil rig, for example. And you say, you know what? I'm going to make a vote that we're going to issue a bunch of new shares. We're going to issue them to me as payments for my leadership role, and it will dilute everyone else. And so you do that, and now you own 99% of the oil rig shares. So what's the benefits of doing that if you're in an oil rig company is that you used to own half an oil rig, and now you own a full oil rig. And of course, you're likely going to be sued, but at least if you succeed, you're going to own a full oil rig. If you try to do that on a decentralized ledger whose only value is that it provides good governance and that it has a token that people can trust and use, then you're essentially shooting yourself in the foot. If you were to pass a law that was extremely biased or to your advantage, essentially people would just desert the platform, and the token that you issue to yourself would end up having very low value. So that's one thing. That's one level of protection. The other level of protection is that there is a mechanism by which blockchains today do governance, which is hard fork. And I don't think that hard forks are a good way to do governance for a lot of the reasons that I outlined. I like to think of a hard fork as a revolution. It's like, you know what, we're going to throw everything out. We're going to throw out of the old rules and put in new rules. And so I think that if some people try to do something like that, what you'll have is that you'll have a hard fork of the platform. People will say, hey, hang on a second, we're not going to go for that. We're just going to hard fork it. And the people who actually try to pull this off will probably lose their stake in this hard fork. So it's unlikely that you would get any benefit from trying to do something like that, and it's very likely that you would incur severe losses. So the question is, what do you do with people who do not vote? So there's two questions here, I think. One is that when we count votes, by default, it can be a vote against, a vote for, or an explicitly neutral vote, and that's +1, 0, and -1, and that's how we tally it. But also, I think the general question is, a lot of people, there may be something called voter apathy, where voters don't actually care to vote. So the way we address that in the system is votes are delegated by default, which means if I'm a user of the system, but I don't care too much about voting in all of the decisions, I can designate someone to make decisions on my behalf. And I can revoke that right, and I can change it. So this is sometimes called liquid democracy, the idea being that I trust this person to make good decisions on my behalf, and if somehow I ever see them make a bad decision, or I hear that they did something bad, I can revoke that immediately and shift to someone else. So that's how we combat voter apathy. But I also think that there's non-voting based solution which we're interested in moving forward to. So one is called future keys. The idea of future keys, you run prediction markets. So you have people trade on the probability that an idea is good. Good meaning that maybe the price of the token increase, or maybe good things happen. You have some sort of verification that says that the idea was good. You have people bet on whether or not the idea will be good, and the idea that is expected to be the best is adopted. So these are non-voting based mechanisms that I think are interesting to explore. All right, thank you very much.